and these are the slant edges which is visible in top view because it's a pyramid. Then draw its axis from the midpoint. This is the center line or axis of the solid, and height is given, that is 60 millimeter. So at a distance of 60 millimeter from XY line on the axis, put a point over here and insert the dimension 60 like this. And this is the apex point of this solid. So join this apex point with this side length, transfer this base, square base to XY line, and join these 2 points with these apex points and complete this triangle. So this triangle represents the front view of square pyramid having side length 40 mm and height 60 millimeter. Now it is given the end points of the base A, B, C, D because it's a top view. So A, B, C, D would be here. Similarly, it's a front view. So A dash, B dash, C dash and D dash are here. The apex point is O dash is here. Now it is given that it is resting on its triangular face. So what should we do? As it's resting on its triangular face, in front view it would appear like this. We have to redraw this triangle in such a way that this O dash A dash comes on XY line like this. Make it parallel to XY line. So this is apex point O dash, A dash B dash are here, C dash D dash are here, and this is the center line of given solid. So this is front view. Now to locate its top view, transfer the points from front view, vertical line from point A dash B dash, from point C, and horizontal line from point A and B. So A1 point is here and horizontal line from point B, B1 point is here. So these are the 2 points which are visible in top view. Similarly, transfer point number C dash and D dash. From that draw a straight vertical line, and from point C and D, D is here, C is here. So from D draw a straight horizontal line. Both the lines will cut at one point, and here also horizontal line from point C, vertical line from point C dash, both will cut at one point. Name the end points. This is point C1 and this is point D1. So we have picked up these 4 points in top view. Now about this apex point O dash. So for that draw straight vertical line from point O dash and horizontal line from point O, and both will cut at one point, and this is point O1, the position of the apex point of this solid. Now if you look from the top side, from here, this base, square base would be fully visible. Hence we join A1, B1, C1, D1 to A1 with a full line, because this bottom face would be fully visible in top view. If you look from top side, this square base would be visible as a rectangle like this. And join these endpoints C dash and D dash with apex point O1 with a straight line like this. O1 to D1 and O1 to C1. And O1 to A1 and O1 to B1 will not be visible if you look from the top side. So join this with the dotted line, O1 to A1 with the dotted line, and O1 to B1 with the dotted line. So this is the projections of solid of given data. So first step of the problem is over. Now second step, a cutting plane is given. A cutting plane cuts the plane parallel to HP and passing through the midpoint of the square base. So here first we find out the midpoint of the square base. It is here. This is the midpoint of this square base, and from this point a cutting plane passes which is parallel to XY line like this. This is the cutting plane which is parallel to XY line and passing through the midpoint of the base. This is the midpoint of the base, and this is the cut portion. So this much line should be full line, and on this side and on this side a dash should be there, long dash should be there, 2 small dash and 1 long dash to indicate that it's a cutting plane. Now find out the points of intersection. So for that, find out point of intersection between cutting plane and the slant edge, O dash C dash and O dash D dash, and this horizontal line. One point is here. So from that point draw straight vertical line that will cut O1 D1 at one point, and similarly transfer this point on bottom side. So O1 C1 that will cut over here. So vertical line from this point, O1 D1 to this point and O1 C1 to this point. 2 points are here. Similarly, here 2 points would be there. One is on AB, AC, and another on BD. So on AD, A1 D1 here. So from this point draw a straight vertical line. It will cut A1 D1 at one point. Similarly, it will cut B1 C1 at another point. So we have picked up more 2 points. Join all these 4 points with a straight line. Lighten this portion and join this with a darken line. These 4 points as we have found the positions. So this is the cutting portion, and in top view, if we cut this prism, this pyramid at this angle, then its top view would appear like this. Darken this portion because it's a remaining portion, it retains with us. This portion is also retained with us. So draw it like lightly darker. So this is the square pyramid sectional view. Now next problem. A cone diameter 60 mm and height 70 mm is resting on HP on its base. It is cut by a cutting plane parallel to one of its slant edge and bisecting the axis. Draw front view, sectional top view, true shape and development of the surfaces. So this problem we solved earlier. Only one step is added in this problem, that is development of the surface. Up to sectional top view, true shape we drawn it previously. So the solution is shown over here. This is the solution of that problem which we drawn earlier. This is the sectional top view. This is front view as shown by the red colored pen, and this is the true shape of the section. Now in this problem, one step is added to draw its development of its lateral surface. So to draw its development of the lateral surface, let me assume that this cone O dash 5 dash to 1 dash is not cut anywhere, and to draw the development of the cone, the first step is to find out its angle theta. So equation for angle theta is known to us, that theta is equal to 360 degree into radius upon length. Radius r means the radius of the cone or base circle. Here radius is 30 millimeter and L means length of its slant edge or true length, distance between O dash to 5 dash or O dash to 1 dash. So measure that distance is 75 millimeter. So angle comes out to be equal to 720 upon 5, that is 144 degree. So that is first step, to find out the angle theta is equal to 144 degree. After that, O dash 1 dash is the true length. So with that O dash 1 dash, draw a line which makes an angle of 144 degree with O dash 1 dash. So that line is to be drawn like this. This angle is 144 degree. This included angle is 144 degree. And take O dash as a center and O dash to 1 dash as the radius, as it's a true length of its slant edge. Draw an arc like this. O dash is the center, O dash to 1 dash is the radius. Draw an arc and divide this circle which we divided earlier into 8 equal parts. Similarly, divide this angle into 8 equal parts by any method, by angle division method or by marking the angles like this. 8 equal parts. So first divide into 2 equal parts, again divide into 2 equal parts of each segment. Then we would be able to divide the total figure into 8 equal parts like this. 144 divided by 8, that would be the included angle in each segment. And name the end points. Here is point number 1 dash, 2, 3, 4, 5, 6, point number 7, 8 and back to 1. 8 points are there over the outer periphery of this arc. So this arc represents that if this cone is not cut at any angle, this would be its development. But here the cone is cut, so for that we have to find out the point of cutting of this cone with the slant edge and this cutting plane. So let me pick up point number 1. O dash 1 dash is here and O1 is here, so it is cut over here by the cutting plane. This is a cutting plane, so cutting plane cuts O1 at this point, so this is point number P1. Mark that point as point number P1. So this is point number P1 on O1. Similarly, point number 2 is here on O2. O dash 2 dash is here. This is point number 2 dash. You can see here, this is point number 2 dash. O dash 2 dash is here. Intersection of O dash 2 dash and this cutting plane is this point. So from that point, draw straight horizontal line. Because this point P2 is not on true length, so first we have to transfer to the true length. Straight horizontal line that will cut O1 at this point, O dash 1 dash at this point, and from this point draw an arc. Take O dash as a center, O dash to this marked point as a radius from here, and draw an arc like this, and that arc will cut O2. This is O dash 2 dash at one point. So this is our point number P2, right? Now P3, here O3, O dash 3 dash is here. On O3 the cutting plane cuts at this point, so from this point draw straight horizontal line like this, means transferring this point to its true length, so it will cut the true length O1 at this point. Now again with the same analogy, take O dash as a center, O dash to this extended point as a radius somewhere here, and draw an arc. So that will cut O3, extend that arc up to O3. So this is point number P3, because this point is on O dash 3 dash. Now on O4, O4 generator is not cut by this cutting plane anywhere, so we skip that portion. Now think about this from here. If you move around on this side, here is the cutting plane or here is the cutting point. This cutting point is in between 3 dash 4 dash and 6 dash 7 dash. So transfer that point to the top view. So point between 6 and 7, one point is here. Between 4 and 3, one point is here. Now our objective is to find out the position of this point in this development. So this point is between 4 and 3 at this distance, and this point is between 6 and 7 at this distance. So how to locate this point in between 3 and 4? So for that, in examination we can roughly estimate this distance 3 to 4, 4 to on this side, between 3 and 4 towards 4 somewhere here. But practically in actual condition, how to find out this position? So for that we need to transfer the distance of this point over this periphery by having its basic concept, that is length of arc. Arc length is equal to radius into theta. So for that, measure this angle, compute, extend this line like this. This point we join with the midpoint, measure this angle. This angle is theta, right? We know this radius, so say this is point number M. So distance M3, that is arc length M3 is equal to angle theta into radius, because we know R into theta is the arc length. So R is known to us, that is 30 millimeter, into angle theta, whatever comes over here in terms of radian, upon 180 degree to convert into degree. This angle will be in degree and convert into radian, for that divided by 180, and this distance shows actual millimeter. But here you need not to do all those exercise. Directly in examination you can put point number M in between 3 and 4 towards 4 somewhere here, just by estimation, because here that much accuracy is not demanded, and it takes lots of time, so which is not needed in our examination. Similarly here, say point number N between 6 and 7 towards the 6, so that would be somewhere here towards 6, that is point number N. Now on the back side, on generator O dash 7 dash, one point is here, so transfer that point to the XY line, again draw an arc taking that point as a radius. So extend this arc arc of P3 point up to P7. So here point number P7 would be there, extension of this arc. Similarly, extension of this arc of P2, this arc extend up to 8, because here it is on O dash 8 dash generator, and here 1, similar to first one. Transfer this point by arc up to here. This is point P8, and this is point number P1. So these are the points. Join all these points with a straight line, with a smooth curve, as it's a cone. So to join all these points with a smooth curve, you can join like this. And on this side also, this is the arc, right? Retained portion, this is straight line, that retained portion, this is straight line, that is the retained portion. After cutting this cone, this portion retains with us, and this 4, 5, 6, point number 4, 5, 6 is removed portion, hence this arc will remain. So this arc and this arc. So finally these 2 points, these 2 chips as shown by blue color will retain with us if we cut this cone at this angle, and this is the development of given problem, right? This problem we drawn earlier, and this is the solution which we have drawn over here. 2 pieces of paper retained with us, and we did hands-on experience how to draw that problem. Now next problem, problem number 4. The data is given. A piece of paper cut as right angle triangle having base 180 mm and height 90 mm is resting, having height 90 mm is rolled to form a cut cylinder. A paper is cut, is rolled into cylinder. Find out diameter of cylinder and draw the curve showing front view. So here data is given like this. A piece of paper is given to us, you can see here